In Module 4, we are going to talk about different chemical reactions. Um, when we think about the chemistry of cosmetic products, right, many of them depend on chemical reactions. So, for example, henna tattoos are one. They turn, so if you've ever had a henna tattoo, they go from kind of this light orange color and over time will turn a darker color on your skin. That's undergoing a chemical reaction called oxidation, which we're going to talk about in this chapter. We are going to balance chemical equations and talk about different types of chemical equations. One of the types that we're going to talk about are acid base equations. This is the reason that bath bombs foam there and give off gas as they undergo an acid base reaction. We're also going to talk about pH, right, and what pH is and the different pHs of some of the products and why it's important for certain products to keep your skin right here at this pH of 4 to 6. And so those are some of the things that we're going to talk about in this chapter. So in any chemistry class, you are going to balance reactions, and that's what we're going to do first. So we're going to talk about the basics of these chemical reactions and how to balance them. So when we look at chemical reactions, right, and chemical equations, what chemical equations are, what they do, is they just describe proportions of reactants and products during a chemical reaction. So when we look at a chemical equation, just to kind of orient yourself, it's helpful to find the arrow. Okay, this arrow is going to separate the reactants here from the products. When we talk about reactants, reactants are just the substances that are consumed. And products are just the substances that are formed. Okay, and the arrow separates those two. When we look at this, there's a couple different ways we can describe chemical reactions. We can talk about them in words. Sulfur trioxide reacts with water to form sulfuric acid. Some of your context clues here for going to the products are to form, right? Or if you see the word produce, right? That's a context clue that we're right there at that arrow. We can write these equations. So we're showing the molecular form here. We can also write these as the chemical formulas. So there's sulfur trioxide, it's SO3 plus water. We know water is H2O, it's also shown there, right? Produces sulfuric acid, which is H2SO4. We can count the atoms here. The white are hydrogen, the yellow is sulfur, the reds are oxygen. Okay, and so we can count those and see that that's what we produce. I want to remind you that when you are writing these chemical equations, please make sure that you are using the proper capitalization from the periodic table, right? Because that is cobalt versus carbon monoxide, right? So if you're not doing that, it can really change the meaning of the chemical reaction. Another thing I wanted to let you know when we were looking at this, that sometimes students ask, is they're like, hey, why is SO3 first and water is second? No real reason. You could change these around. You very well could say H2O and put H2O first and SO3 as they're separated by that plus. It's kind of like if you say 3 plus 2 or 2 plus 3 in math. Okay, so it doesn't matter which one comes first. So there's some other things that you can see in balanced reactions. one of the things that you can see in the balanced reaction is parentheses with a letter in it. The letter just tells us the physical state of the products and reactants. So S is solid, L is liquid. The L is normally a cursive L. G is gas, and AQ is aqueous. Aqueous just means mixed with water. All right, so it's dispersed in water. When you read a chemical reaction, one of the ways that we can interpret this is we can say one molecule of sulfur trioxide reacts with one molecule of water to form one molecule of sulfuric acid, okay? And then again, the arrow here is to form or produces or yields. All of those are those verbal clues that we're going from reactants to products. Now, in some chemical reactions, you're going to see a number in front of the chemical species. And so in this chemical reaction, we see two numbers. We see a number here and a number here. These are called coefficients. And this is what we change when we balance a chemical reaction. You will notice here there is no coefficient. That's because the coefficient is 1, and 1 is understood and generally not shown. Sometimes if you go out to the internet, sometimes you will see ones here. That's okay, but most of the time they're not shown. So the way we would read this is we would say one molecule of iron oxide reacts with 3 molecules of sulfuric acid, and it forms 3 molecules of water and 1 molecule of iron sulfate. And so this just tells us the number of molecules. Now, a few other things that you can run into in balanced reactions that are important to kind of point out, and has to do with the arrow. Sometimes you'll see an arrow with a little triangle. That triangle just means heat. So sometimes we'll put reaction conditions around that arrow. It can be something along the lines of a temperature, right? So we're gonna put these reactants together and heat it up to 180 degrees. Sometimes you can even have reagents around the arrow, like things like catalyst. So these are other things that you'll see in chemical reactions that I just wanted you to be aware of. So let's talk about balancing chemical reactions. So balanced chemical reactions and equations follow the law of conservation of mass, right? That says matter can neither, I don't like the way I said that, let's say cannot be created or destroyed, okay? And so what that means for us is we need to have the same number of atoms in the reactants that are in the products. So those need to match. So if we look at this chemical reaction here, we're comparing reactants to products when we're evaluating if a chemical equation is balanced. There's 1 carbon here, there's 1 carbon on this total side. So carbons are the same on each side. That obeys the law of conservation of mass. There's 1 nitrogen here, there's 1 nitrogen here. That obeys the law of conservation of mass. We have 7 hydrogens here, but we only have 3 hydrogens here. That does not obey the law of conservation of mass, because what it says is, hey, look, we had 7 here, we only have 3 here. Where did those 4 hydrogens go, right? That would be something being destroyed or lost. So this reaction is not balanced. So we're going to balance it on the next slide. So here's some kind of, here's a 4-step method for balancing equations. I'm also going to give you some kind of tips and tricks and helpful hints. So the first thing here is you need to write the correct formulas for reactants and products, including the physical states. That including the physical states is important, but it does require an asterisk if those are given, right? If they're not given, you don't have to include them, but if they're given, you need to include the physical states. So we've got CH4 as a gas plus NH3 as a gas, and that's producing HCN as a gas and H2 as a gas. So the next step is check whether the expression or equation is balanced by counting atoms on each side of the reaction. Now, when I do this, I like to make a list below the reactants and a list below the products. So for example, I come over here and I say, hey, look, we have one carbon atom here and we have one carbon atom here. We look at nitrogen, we have one nitrogen here and we have one nitrogen there. Hydrogen, we have 7 hydrogen here, and hydrogen here, we only have 3, right? We've got 1 here and 2 here. Now, then the next step here is it says balance an element that appears in only one reactant and product first. Now, what does that mean? Well, when we look at this, you've got hydrogen in CH4 and hydrogen in NH3. So you wouldn't want to balance the hydrogens because the hydrogens are in 2 different chemical species on the same side. Same thing going on here. You would want to start with the carbons and the nitrogens first. Other kind of tips and tricks that are helpful when we balance chemical reactions, my suggestions are leave hydrogen and oxygen last. A lot of times these just are in multiple elements, and so it's really helpful to leave those to last anyway. And if you can balance all of the other elements, then a lot of times these just happen to fall out. They balance because everything else gets balanced. So leave those to last. The other thing that's really helpful is leave individual elements last. So these are elements that are all by themselves. An example of an individual element would be H2. You've only got hydrogen to worry about in that one. Other tips and tricks, right, is with polyatomics. If you have a polyatomic ion that is the same in the reactants and products, balance that as a whole. And I'm going to show you an example of that because that's really helpful. So when we come here, as we look to balance this, we've got one carbon here and one carbon here, and those are balanced. We've got one nitrogen here and one nitrogen here. If I put a number in front of the carbon here or the nitrogen here, that is going to change. I'm going to have to come over here and put a number here. So the best thing to do here would be to see if we can balance the hydrogens here and here without messing with any of the carbons and nitrogens. When you're looking at which side you want to put a coefficient on, we're going to want to put a coefficient in front of something over here because the coefficients can increase the number of atoms, right? We don't need to increase the number of hydrogen atoms here. We need to increase the number of hydrogen atoms here. So I'm going to come over there and I'm going to say, okay, if I put a 3 here, right, then that's 3 times 2, that gives me 6 hydrogen atoms. And I have 1 hydrogen atom right there. So 6 plus 1 gives me 7, and now that equation is balanced. Let's do another example. So I am just going to omit the states just for brevity of this screencast. So we've got nitrogen, reacts with hydrogen, and that goes to NH3. Okay. If you want to practice this, you could try to balance it on your own, pause the screencast, and then come back and double check. I'm going to go ahead and work through it. We've got nitrogens. We've got 2 on this side. Nitrogen, we only have 1 on this side. Hydrogen, We've got 2 on this side. Hydrogen, we have 3 on this side. So when I look at this, the first thing I'm going to mess with is nitrogen. I'm going to leave that hydrogen is the hydrogen and oxygen, right? Leave it to last. So I'm going to start here with my nitrogen. I've got 2 here and 1 here. I have less on this side, so that indicates that's where I need to put the coefficient. So if I come over here and put a 2 here, that means that now I have 2 nitrogens. But I haven't just affected my nitrogens, I've also affected my hydrogen. So 2 times 3 gives me 6 there. Okay, so my nitrogens are balanced. We have to look at the hydrogens. We need to come back to this side because there's fewer here, so that indicates that we're going to put a coefficient on this side. And so if I put a 3 here, 3 times 2 is 6. And that equation is also balanced. We're going to do one more where we look at polyatomic ions, because remember I said we could balance polyatomic ions as a whole. So we've got ammonia sulfate plus lead nitrate is going to ammonia nitrate and lead sulfate. Now, when I look at this, I've got NH4 here, that's an ammonia polyatomic ion. I have NH4 here, that's an ammonia polyatomic ion. It doesn't change, it's NH4 in both places. So I'm going to come here and I'm going to say, hey, look, I've got 1 NH4 here. I have 1 NH4 here. I don't have 1. I have 2 NH4s. Sorry about that. Okay. I look next at the sulfate. I have 1 SO4 here and 1 SO4 here. I look at lead. I've got 1 lead here and 1 lead on this side, and then the nitrate I have 2 on this side, and the nitrate I have 1 on this side. So when I look at this, I have 2 ammonias here and here, two ammonias, and then 2 nitrates, and here I only have 1 ammonia and 1 nitrate. I see that ammonia and nitrate are in the same chemical complex. So if I put a 2 right here, that will change that to a 2 and that to a 2. And so now I've got 2 ammonia nitrates. And so you can see here where everything is balanced. Now, one of the things I love about this is you can always come in and double check these. So you can always count and make sure the number of atoms on this side equals the number of atoms on this side. We'll do more balancing equation practice in class. So if you're feeling a little overwhelmed, don't worry, we're going to talk about this a little bit more. There's one last thing that I wanted to talk about, and that is diatomic elements. We mentioned this when we were doing some of our introduction to the periodic table. It's really helpful to remember that nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen all occur naturally as diatomic elements. So if I say hydrogen reacts with nitrogen, you're going to put an H2, not just a hydrogen all by themselves, like an H, right? So we'll talk more about that, but I just wanted to come in and revisit that these are the ones that you have to remember are diatomic. It's really nice. There's 7 of them. They make a 7 on the periodic table with the exception of hydrogen. So when we're balancing, we'll want to really remember that these are our diatomic elements.